So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the AQA GCSE Maths November 2018 Higher Paper 3. I will include a copy of the paper and a copy of the grade boundaries in the description below for you to download and have a look at once you've completed the paper. I'll also include the overall grade boundaries for this series of papers. So let's get started on this 2018 November Higher Paper 3. Looking at question 1, it says that a shape is translated by the vector of 0, 4, and it says in which direction does the shape move. So here you can see from the top number we've got 0 horizontal movement, but we have got a positive vertical movement, which implies that we are moving up. Then with question 2, it says what is 1.75 kilometers as a fraction of 700 meters. So here what you want to do is make sure you've got the units in the same for both numbers. So here you've got 1750 over 700, or 1.75 over 0.7. And if you enter that on your calculator, it should tell you that the correct answer is 5 over 2, or 2.5. With question 3, it says the first 4 terms of a linear sequence are 3, 11, 19 and 27. Circle the expression for the nth term. So here what we want to do is work out what the nth term is. So we've got a difference of 8. And what do you have to do to 8 to get to 3? Take away 5, so it's going to be our last option. With question 4, it says work out the lowest common multiple of 20, 30 and 40. So you're looking for what's the smallest number that appears in both the 20, 30 and 40 times table, and that's going to be question 5. It says the length of a table is 110 to the nearest centimetre. Complete the error interval. So here we've got a nearest centimetre, so we divide that by 2, which we get 0.5. So it's 110 plus or minus 0.5, which gives us a lower limit of 109.5 and upper limit of 110. Then for question 6, it says a music festival has taken place in each year from 2011. The table shows the number of people who attended each year. The festival organisers draw a time series graph to represent the data. First 4 are done for you, and I'm guessing that we then to graph. So they've done 4, so what we need to do is then plot these, and we'll try and do it to the best of our ability. So what we're going to do is just zoom out so we can see both things. 2015 is at 2023, so it's going up in hundreds. So I would say it's relatively quite close to that 2000 there. Then for 2016, it's close to 2100, so it's there. Then 2017, it's at 3251, which is in the middle between 3 there. And then for 2018, it's at 378. And what you then want to do is draw straight lines with a ruler connecting up, and you want to make sure that you are joining them up. So let me just join points. Then if we look at the second one, it says use the graph to estimate the number of people who attended the festival in 2019. So again, if we look at the general trend, we can see that it's pretty much going up by 1 box, I would say. So here I would say anything along the lines of, as a decent guess, between 4,200 to 4,500 would be an estimate using your graph. Moving on to question 7, it says that we've got k equals n squared plus 9n plus 1. Mo says that k it will be a prime number for all integer values from n from 1 to 9. Show that Mo is wrong. You must show that your value for k is not. So for here, if I substitute, so if n equals 1, 2, 3, 4, 5, 7, 9, what we're going to do is substitute it all into the values and hope that we notice that one of these numbers is prime. So if I substitute n equals 1 into this, I've got 1 squared plus 9 times 1 plus 1. It'll be 2 squared plus 9 times 2 plus 1. 3 squared plus 9, 3 plus 1. 4 squared plus 9 lots of 4 plus 1. 5 squared plus 9 lots of 4 squared, 4 plus. Last one's going to be 9 squared plus 9 lots of 9 plus 1. And if I work that all out, and what I should get is 11, 23, 37, 53, 71, 91, 113, 137, and 63. Now what I'll do is just check to make sure that any of these is prime. So here 11 is prime, 23 is prime, 37 is prime, 53 is prime, 71 is prime, 91 isn't. Now if you've got your calculator, particularly a Casio calculator, check these are prime. Basically what you want to do is enter the number, press equals, and then use your fact button. Now if it comes with a POTP or product to the primes, it means it's not prime. If it comes up with the same number, it means that it is a number. So 91 is not prime, so 91 is not prime, and it says that we need to show proof of why it isn't, and then it's not prime as 13 times 7 equals 91. So basically 13 is a factor or 7 is. Then moving on to question 8, it says Doug owes an amount of £600. He wants to pay this off the amount in 5 months. He says that each month if I pay about 20% of the amount I still owe, show working to check to see if his method is correct. So this is a compound interest question. So here let's have a look. So his starting amount is 600, and we're going to multiply that by 20% off. So starting with 100, take away 20 gives us 80%, and we're going to pay that over 5 months. So if I type that all into my calculator, what do I get? Well, I get 196.61. So that's how much there is still left to pay. So basically, no. As this is not 0, still payment to pay. So he is welcome. So something along those lines would be absolutely fine. I would say for that calculation you get 2 marks, and something just to summarise why it's wrong, get either one. And looking at question 9, so it says that a motor racing circuit consists of 2 parallel straight sections, each of length of 0.75 kilometers, semicircle of a diameter of 0.9, and 3 equal smaller semicircles. The length of the motor race must be greater than 305 kilometers. What is the lowest number of full laps needed at this circuit? So what we need to do first is work out the perimeter. In other words, so we notice that we've got a couple of sections. So here we've got these 3 semicircles. Got 3 semicircles, and that's going to be 3 times, and then to work out the area of the circumference of a semicircle, it's pi times the diameter, which is 0. And then we've got this big semicircle, which is pi times that by, and I've got pi times 0.9 divided by 2, and I've got the 2 straight edges, which is 2 times 0. And if I work out each of those bits individually, I get an answer of, so for the first 3 semicircles, it's about 1.413. For the large semicircle, I get 1.413. Makes sense that they're both the same. And for the two straight edges, so if I add all of them up, I get that the lap distance is going to be equal to 4.327 kilometers. That's been rounded. Then in terms of the total number of laps, is I do the minimum distance, which is 305 divided by the lap distance, and that gives me an answer of around about 70.485. So then total number of laps needed is going to be 71 laps. So moving on to question 10. So this is looking at inequalities. Now, there's several ways in which you can do this. So as long as your final answer looks the same, it is entirely up to you how you do this. I always say, whenever you've got a negative x, always take it to the side to make it positive. So here what we've got is to take that negative x over to the side, end up with 8 plus a half x is greater. Then I get rid of the 8, so I've got half x greater than minus 5. Then I take the half over, I end up with x greater minus 10. Now, if you have minus 10 is less than x, then that is absolutely fine. As long as the inequality is pointing at the minus 10, it's all good. For question 11, it says use trigonometry to work out the size of angle x. So here we need to label the size. So that's the hypotenuse. This is the adjacent. This is my theta. So which rule am I going to use? I'm going to use cos. So I've got cos x equals the adjacent, which is 9, over the hypotenuse, which is 10. So the inverse cos of 9 over 10 equals x. And I get an x value of around about 25.8419. Again, if you want to round that up, it'd be 25.8, and that's to place. Looking at question 12, it says Lewis wants to draw the graph of y equals x cubed to find the values of minus 2 to 2. Here is this graph, and it says make one criticism of the graph. Now I would say the obvious one is that he's joined points up with straight lines should be smooth. Something along those lines would be absolutely fine. It's just worth just double checking to make sure his values are right. These values are pretty spot. Moving on to question 13, it says the probability of heads on when a biased coin is thrown is 0.6. The coin is thrown 500 times. Circle the expected number of tails. It's really important that here we're looking at tails, but the information we're given is heads. So the probability of a tail is going to be 0.4. So I need to do 0.4 times 500, which gives me an answer of 200. Then with question 14, it says that the mean mass of a squad of 19 hockey players is 82 kilograms. A player of mass 93 kilograms joins the squad. Work out the mean mass of the squad now. What we need to work out first is the total weight of the 19 players. That is done by doing 82 times 19. So 82 times 19 gives me an answer of 158. Then if I add the new player, which is 93, then it comes up to a total weight of 1651 kilograms. Now I want to work out the mean. So then the mean, say the new mean, is going to be 1651 divided by, well, there was 19 players to start with, a 1's joined, so it's now 20, and then that gives me a new mean of 82.5. So looking at question 15, it says the company makes two types of lampshade using fabrics on wire frames. So lampshade A, fabric is used to make the curved surface of the cylinder. The cylinder has a radius of 8 and height of 22. Lampshade B, fabric is used to make 4 triangular faces of the pyramid. Each triangular face has a base of 15, perpendicular height of 24. Got some costs and some measurements there. question's asking us to work out the ratio of the cost of one lampshade A to cost of one lampshade B, and we give our answer in the form of x to 1. First of all, let's work out the fabric cost. So here, in terms of the surface area, fabric needed, do that first. So here we've got the cylinder. The formula for that is 2 pi r h, because we're only wanting the curved bit, we're not wanting the circles. So for this, we're looking at square meters. So I would say that we're probably better off converting these lengths into meters. So rather than using 22 centimeters, I'm going to use 0.22 meters. 8 centimeters is going to be 0.08 meters. Likewise, this is going to be 0.24 meters. This is going to be 0.1. Again, the reason why converting those units into meters is because the cost of the fabric is written in square meters. So looking at this, then let's work out what the fabric we're going to, how much fabric we need. 2 times pi times 0.08 times 0.2, and if I work that out, I get 0.110584 meters squared. Then if I then work out what the pyramid is going to be, which is just 4 triangles, and that's going to be 0.15 times 0.24 divided by 2. You need to multiply that by 4 because I've got 4 triangles, and that gives me a total length of 0.072. The next thing I then need to do is work out the cost of fabric. So for the cylinder, for A, it's going to be 0.11058 times 400 meters per square meter, and that gives me a total cost £44.20. Then for the pyramid, it's B, going to be 0.072 times 400, and that comes up to a cost of £28. And now for this, what I then need to do is add on these two amounts. So here, if I've got A to B, I've got 44.23 to 28.0. I've got to add £3.50. This one I've got to add £7.50, and that comes up to a total of £47.47 to £36.30. Then what I want to then do is, because in the question it says to make it in the ratio of n to 1, I need to make the lampshade B equal to 0. So I'm going to divide that by 3630. I'm going to divide this by 3630. So this then becomes 1, and this becomes 1.32, and there. Now moving on to question 16, it says that in a running club there are 50 females and 80 males. If a female is chosen at random, the probability that she has blue eyes is 0.38. If a male is chosen at random, the probability that he has blue eyes is 0.6. And one person is chosen at random. Show that the probability the person has blue eyes is more than 0.5. So for here, let's have a look at the number of females. So females with blue eyes. And that's going to be done by doing 50 times the probability, which is 0.3, gives me an answer of 18. Then we look at the males with blue eyes, and that's going to be 80 times 0.6, which gives me 48. So the total number of blue eyes, so people with blue eyes, is going to be 19 plus 48, which is 7, and the total number of people is 50 plus 80, which is 130. Now 67 over 130, if I type that into my calculator, 67, me an answer 0.513846 blah blah blah. And as you can see, this is more than 0.5. And for question 17, it says W equals 3 over 5 root x, and it says circle the expression for W squared. So if we square all of this, well, 3 then becomes 9, 5 becomes 25, and root x then becomes x. So that's what we're looking for, and that's alpha. And looking at question 18, it says here is some information about the ages of people at a concert, and what we need to do is draw a histogram to represent the information. So for this, what we need is a couple of columns. So we need our class width and we need our frequency density. So our class width is basically our upper bound take away our lower bound. So for the first one, it's going to be 5, then 10, then 15, 30. Then we need to work out our frequency density. And how do we do that? Well, we just simply divide the frequency by the class width, in which we should have answers of 1.6, 0.4, 2, and 0.3. So then what we need to do is draw these values between these limits. It's really important we do get this correct. So 10 to 15 is 1.6. Going up in, say, 2's, 1.6 squares above there. Again, you should be using a ruler. And then the next one, is at 2.4 between 15 and 25. So 15 and 25, so it stops there. At 2.4, so it's just 2 squares below 5. Mine's going to look really bad. Ruler should. And then the next one, 25 to 40, is at 2. Finally, 1.3, so that's 42. Histogram should So question 19 says the length of a roll of ribbon is 30 meters, correct to nearest half meter. The place of the length 5.8 meters, correct to nearest 10 centimeters cut from the roll. Work out the maximum possible length of the ribbon left roll. Now for this, what you need is to have the biggest roll that we could have is going to be 30, and then we've got the nearest half meter. So nearest half meter is going to be 0.5. Divide that by 2. And that's going to give me 30 plus 0.25. So the biggest roll is going to be 30.25 meters. Now what we want then is the smallest cut, because we want the biggest amount left. And so we've got 5.8, and then plus or minus the nearest 10. So it's 10 divided by 2, which is 5. And so actually it should be 0.05 in terms of there. Okay. And so that's going to be 5.75. Then if we take the two numbers away, so I've got 30.25 minus 5.75, should get an answer 24. Then moving on to question 20, it says curve P has the equation of y equals 2 lots of x minus 1 squared minus 5. Curve Q is a reflection in the y-axis of curve P. Work out the equation of curve Q. Give your answer in the form of y equals ax squared plus bx plus c, where a, b and c are mixtures. Now here what we need to do is look at graph transformations, and that when we are reflecting in the y-axis, we change the sign of x. So to reflect in the y-axis, change the sign of x. So what we're going to have then is y equals 2, and it's going to be minus x minus 1 squared minus 5. So what I'll then want to do is expand this out and show it equals this. So first of all, let's work with minus x minus 1 squared. So looking at this, minus x times minus x is x squared. And I've got plus x plus x plus, that gives me x squared plus 2x plus 1. Got y equals 2 lots of x squared plus 2x plus 1 minus 5. Then multiply everything by 2, so I get 2x squared plus 4x plus 2 take away 5. Then neaten this up, so I get y equals 2x squared plus 4x minus 3. Then for question 21, it says Priya and Joe travel the same 16.8 kilometer route. Priya starts at 9 AM and walks at a constant speed of 6 kilometers per hour. Joe starts at 9:30 and runs at a constant speed. Joe overtakes Priya at 10:20 AM. At what time does Joe finish the route? So for this, what we need to do is, now we know that they both meet at 10:20. So first of all, let's do 80 over 60, because we want to work out in terms of the times. Now we want to work in terms of minutes. So here that we know that Priya takes 80 minutes before she walks for 80 minutes. Priya walks for 80 minutes, which is basically an hour and 20 minutes. And we multiply that by her speed, 6. And because what we want to work out is at what distance in that 16.8 kilometer route did they meet. So this is her time times speed, which equals distance. Then for Joe, he's walked at a speed of, he's run for 50 minutes. And his speed is what we don't know, so we're just going to call that t. T, Joe's speed equals t per hour. It could be absolutely any letter. Those two things need to equal same, because obviously they meet at a point, so they must have met at the same distance in terms of that 16.8. So if I then work this out and just do some rearranging, we find that we've got 8 equals 5 over 6t. So take the 5 over 6 over to the other side by dividing by 5 over 6, and we get that t equals, which is probably not the best letter to use because obviously t can simplify as time, but we get 9.6 kilometers per hour. So that is Joe's speed. So now that we know what Joe's speed is, what we can then do is then work out his time. So the distance is 16.8, the speed is 9.6. So now what we need to do is work out the time. So the time equals distance, which is 16.8, divided by 9.6, and that gives me an answer of 1.75 hours. Now 1.75 hours equals 1 3/4 hours, and 3/4 of an hour is 1 hour 45 minutes. So what I need to do, if he starts at 9:30, so 9:30 AM plus 1 hour and 45 minutes, well, that's going to give him a finish time of 11:15 PM. So moving on to question 22, it says that approximate solution to an equation is found using the iterative formula xn plus 1 equals xn cubed minus 2 over 10 with x1 equals 1. And the question is asking us to work out the values of x2 and so for this, what I need is to get my calculator. Got it here. Now what you want to do first is enter the first number, which is minus 1, press equal. The next thing we then need to do is set up our fraction, and we set up the iterative formula. Wherever we see an xn, we're going to use instead. Here I've got ans cubed all across minus all down. So x2 is going to be minus 0.03, and then for second value, if I press equals again, give me an answer 0 minus 0.2027. Then to work out what the solution is to 5 decimal places, if I get the calculator out, long as I've not touched it, if I just press equals, what I'm looking for is where the value stabilizes. It's very quick to stabilize. So I'm going to round this number up on my calculator to 5 decimal places. What answer does that then become? Well, it becomes minus 2, 0 point, say 0.20081. Then moving on to question 23, it says the diagram shows the side view of a step ladder with a horizontal strut of length 48 centimeters. This is the strut is 1/3 of the way up from the ladder, so this 1/3, 2/3, and the symmetrical cross section of the ladder shows 2 similar triangles. Again, we're looking at similar triangles. So in terms of this, what we know is that 48 centimeters equals 2/3. So then this length here must equal 2/3. So 2/3, so 2 parts equals 48. Then 3 parts is going to be 48 divided by 2 times 3, which gives me an answer 70. This distance here is 70. Now the next thing we then need to do is we want to work out the height of that. Well, if I simply put this into 2, and notice that I've got a right angle triangle. So this length here is going to be half of 70, which is 36. This is 141. H is what I'm wanting to count. So here what I've got then, using Pythagoras, I've got h squared equals 141 squared minus 36 squared. H equals the square root of 141 squared minus 36 squared. And I should get an h value of whatever that is 18585. So h equals value of 136 centimeters, and that's to 1 decimal place. So moving on to question 24, it says the volume of a sphere is 4/3 pi r cubed, and the volume of a cone is 1/3 pi r squared h. The sphere has a radius of 2x, the cone has a radius of 3x and a perpendicular height of h. The sphere and the cone have the same volume. Work out the radius of the cone to the perpendicular height of the cone. Give your answer in the form of a to b, where a and b are integers. So let's first of all look at the volume of the sphere. It says that they're both the same, so volume of. So let's look at substituting these values in. So I've got 4/3 pi r equals 1/3 r squared. Now we know what the radius of the sphere is, so if I substitute this in, I've got 4/3 pi 2x cubed equals 1/3 pi, radius of the cone is 3x squared. So simplifying each of these, let's just do just that. Just get different. So here we've got 4 pi 8 cubed, 4 divided by pi 9x squared. So then if I start simplifying all of this, I get 32 pi equals, I can simplify this 3. 32 doesn't go into 3, so I'm going to leave that as it is. And I can cancel the pi because they've both got pi. Get rid of this x squared, and we says we've got 1x. I think that's pretty. Let's just simplify all this. So 32x over 3 equals 3h. So from this, I can then work out what h is. So h equals 32x over 9. Again, doesn't really simplify. And so from this then, what I've then got is the radius of the cone against the perpendicular height of the cone. The radius of the cone is 3x and the height is 32 over 9x. So from this I can then cancel the x's. So here I've got this, but I want to write them so they're all integers. So I can then take the 9 over to the side, giving me 27 over 32. And moving on to question 25, it says ABCD is a quadrilateral. The quadrilateral is reflected in the line of x equals 4. That's reflected this line here. The question is saying which vertices are invariant. Now, invariant means basically don't move. So which two coordinates don't move? Let's see. Then looking at question 26, it says here we've got the function and we need to work out the inverse function. So again, looking at the steps, we make it equal to y. And as we've got x's on both sides, on the numerator and the denominator, I can put the denominator in brackets. Then take this over to the side, so end up with y x minus 4 equals 3x plus 3. Expand the brackets, so I get xy minus 4y equals 2x plus 3. I'm going to move over here. We want to get all the things with x's on one side and everything else on the other. So I've got xy minus 2x equals 3 plus 4y. Factorize this left hand side, so I've got xy minus 2 equals 3 plus 4y. Then I'm going to take this over to the side, so I end up with x equals 3 plus 4y over y minus 2. From this, what I then want to do is I replace the x with the inverse function, and wherever I see a y, I swap that. What I've got is I've got the inverse function of x equals 3 plus 4x over x minus 2. Then looking at it says the line y equals 3x plus p and the circle x squared plus y squared equals 53 intersect at points A and B. P is a positive integer, so that the x coordinates of points A and B satisfy the equation. What we want to do is we want to substitute this equation into this one. So wherever I see a y, swap it with 3x plus. So from x squared plus y squared equals 53, I'm going to swap this y with this. So x squared plus, it's going to be 3x plus p squared equals 53. So now what I then want to do is expand that out. It's over here, 3x plus p, 3x equals 9x squared plus 3xp plus 3xp squared, which gives me 9x squared plus 6xp plus p squared. So here what I've got is I've got x squared plus all of that, and then what I then want to do is make it all equal to 0. So what I've got is I've got x squared plus 9x squared plus 6xp plus p squared minus 53 equals 0. And then all that's left for us to do is neaten this up by collecting our like terms of the coefficient of x squared, which gives us 10x squared, and then we've got plus px, 6px plus p squared minus 53 equals 0, which is exactly what they wanted us to show. And then looking at question 28, it says that here is a sketch of a quadratic curve. The turning point is 3 minus 2. Circle the correct statement about the gradient for x is less than 3. So here for x is less than 3, we're looking for this gradient here. And so from there, the gradient is negative. That there concludes the end of this paper. Now we'll include the grade boundaries in the description below, so once you've marked your paper you can see what grade you've got for this individual paper. I'll also include the total grade boundaries for the November 2018 papers, so if you've done all 3 papers now you can then total up your scores and see what overall grade you obtained.